Hello, today we'll be working on LeetCode 1823, find the winner of the circular game. We're given a number called n and a count called k. What they want us to do is imagine that the numbers are in a circle. The numbers start at 1 and go up to whatever value n is. We start at 1 and we move a pointer around this circle k amount of times. K is how many spots we need to move. When we start moving the pointer, we include the number we start on. So in the example they give us, n is 5, so we have 5 numbers, and k, or our count, is 2. So we start at 1, which puts our count at 1, and then we move to the number 2, and our count is now at 2 as well. So we're finished counting because k is 2 and our count is 2, so whatever number we land on is removed from the circle. Then we repeat the process. We start counting with the number right after the number that has been eliminated. 2 was eliminated, so we start counting at 3 for the next loop. The last number standing is the value we return. So I'm going to show you 2 ways of doing this. The first way, we'll use a linked list, and the second, we'll primarily use math. I'm going to show examples and solutions for each way of doing this. Using a linked list, we can model the example that they've given us like this. However, you may notice that once we reach the end of the list, we're at null. When we create our linked list, we'll make it a circular list by pointing the tails next to the head. We can see that this models their diagram perfectly. Let's talk about what our algorithm will end up looking like. So whichever node we're currently on, we'll refer to as the current node, and the node before the current node will be the previous node. So we'll start off with our current node is 1, and the previous will be 5. So we'll start counting at 1 and move our pointer to the next node in the list until we've hit the same value as count. Each time we move the pointer, we'll update our previous to whatever current was previously. Once we move k amount of times, we need to get rid of our current node. So how do you get rid of the current node? So you get rid of the current node by pointing previous's next to the current's next, like this. Then, prepping for the next repeat of the algorithm, we need to move the current to the current's next. Okay? And we just repeat that process. So our first time, we started at 1, we counted 1, 2, and that removed 2 from the circle, and we pointed the previous to 3. Alright, and then our current was moved to 3, so then we count 3, 4, 4 is removed, update 3 to point at 5, and move current to 5 as well. Then we have 5, 1, 1 is removed, the previous is next, points to 3, and the current's moved to 3, and we count 3, 5. Alright, so 5 is removed. The previous will now point to 5's next, which is 3, and the current is also moved to 3. So at the very end of the algorithm, when the previous and the next are exactly the same, that's how we know that we're finished. Okay, moving into the code, so the first thing we'll make is a function for creating list nodes, and this function is going to be similar to the function you'll see LeetCode use for their linked lists. The next function is create circular list. This takes an amount of nodes we want to create. We'll need a reference to the head and the tail of the list, and then we'll default them to null. So we need a way to create multiple nodes. So we'll use a for loop and loop for however many nodes they want. We'll create a new node for our list, and they want us to start counting at 1, so we'll add 1 to I. So that makes our first node, instead of it being 0, it'll be 1. So if our list doesn't have any nodes yet, the head will be null, so the tail and head will both be the first node, alright? And then every loop after will update the tails next to point to the node, and then set the tail to this new node. So once we're done looping, we don't have a circular list yet. To do this, we'll point the tails next at the head. So this completes the loop. Then we just need to return the head and the tail in an object, or you could use an array as well. Now onto the main piece of the problem. First, if k is equal to 1, we can return n, because whatever number we're on, it would immediately get eliminated, meaning the very last number of n would win. We could leave out this line and it all work the same though. So the next step is to create our list. So pass n to create circular list, and we can destruct the head and the tail to be current and previous. Alright, now we can play the game. So let's create a while loop, and we'll loop while the current node is not equal to the previous node. So if this is true, that means we have one node that is pointing to itself, which means we can return its value. So in the while loop, we'll create a for loop and start I at 1 because we include our current node in the count. So 1 is the count for the first node. So I hope that makes sense. So this will loop k times. Each time we loop, we set the previous node to the current and the current to its next. So after leaving the for loop, we'll update our pointers. Both our current node and previous next point to the current node's next. So go back to the diagrams if you need a visual of this. Updating the pointers removes the node from the list, so it's out of the game. When we finally break out of the loop, we can return the value of the node for our answer. So let's go ahead and submit this. Alright, dope, our solution is accepted. There is a better solution to this though, so this algorithm would have a time complexity of O n times k and the space complexity of O of n. So for each number in n, we need to do k iterations. And the space complexity is O of n because we create a node for each number in n, for the amount of n. So I do have another solution. This solution is focused more on math, and it took me a bit to visualize how this was working. So we're going to start off with a recursive solution, and understanding this recursive solution will help with understanding the iterative solution that I'll show you. So let's say n is equal to 1 and k is equal to 2. So that means we have one person. So if we have one person, they're the winner because they're the last person in the group. So knowing that, if we add another person, the winner of the two people will be k, or 2 places away from the winner of the one person group. So something I want you to keep in mind is that these numbers that I'm showing you represent the positions of the people, not their actual original numbers like we've seen with the nodes and everything. Let's say n is equal to 2 now, so we have a 2-person group, and k is equal to 2. So we move 2 places again. So previously the winner was 1, so we take that position and we count, alright, so 1, and then we count 2, and we're back at 1 because 2 was the last person. So for a 2-person group, the person at the 1 position would be the winner. Alright, so let's add another person. So we have a 3-person group. So 1 was the previous winner, and we count 2 away from it. So 2 and then 3. So 3 is the winner here. Alright, so we add another person. So 3 was our previous winner, and then we count to 4, and then we're back at 1 since 4 was the last person. So 1 is the winner for a 4-person group. Alright, one more time. So we have a 5-person group. 1 was the previous winner. We count 2 away from it. 2, 3. And 3 is the winner of the group of 5, which is the correct answer. So the winner of a specific level is built off of the winners of the level below it. So let's put this in the code. We create a helper function that'll take n and k. So if we're only at 1 person, we return 0 because we're going to 0 index our numbers, alright? And that's the position of the winner. So 0 indexing will help us with the next part of the algorithm, and I'll explain more when we get there. So if it isn't 1 person left in the group, we'll do a recursive call with our helper, and we'll subtract 1 person from the group. So we add k to the result of the call, and this moves the result of the winner k amount of steps to the winner of that group. Alright, so lastly, and this is why we 0 indexed, is we do modulo n to the result of moving our winning position, okay? So we do modulo n to make sure our position is between 0 and n to keep it in the range. So we can think of modulos looping our counter. So we zero indexed, so if we hit the last number in that group, it takes us back to the very first position being 0, okay? So we'll now call helper with n and k, and since the number that we get back from our helper will be 0 indexed, we add 1 for the correct answer, and that's it. So here's a table for the recursive calls, and the time complexity for this algorithm is going to be O of n, because we do n amount of calls, and the space complexity is O of n, because we have to store each call in memory. Alright, so moving on to the iterative version, we're going to create a winning position variable that is set to 0, because we're going to 0 index again. So if we look at the recursive table, we can actually start our loop at 2, because setting I to 1 will always give us the 0 position as the winner when we modulo it. So the first loop doesn't do anything to change our initial answer. So to model the recursive version, we say winning position is equal to winning position plus k in parenthesis, and then we modulo I it to keep the result, the answer, in our range of the amount of people in the group, alright, which is I. Alright, so once the loop is over, we add 1 to the answer to make it 1 indexed. I also made a table for the loops, so in this case I included the first loop to show us why we're not including it. Alright, so I hope y'all learned something from this. It took me a while to visualize what was happening with the later algorithms, so hopefully you understand it now as well. If you have any suggestions, please leave a comment below, and I'll see you in the next video.